Thank you for tuning into the videos. So let's learn about the greater hexagon for trigonometric identities. So here we are going to learn on simple tricks on how to derive the formulas about identities. So I will use a hexagon, and this hexagon is the one which will be leading us. So for this case, I'll have here my tangent. Then tangent, from the knowledge, is the opposite of cotangent. Cotangent. Then you must be knowing that from this hexagon, the C's should be the right hand side. So it is C and C here. And tan is given by sine divided by cos. So this one will be my cosine. Then the other one is cosecant, noted as that one. Then the remaining one is secant. So guys, let us now see how they are coming. Tan is given by sine all over cos. Let's say tan of x is given by the sine of x divided by the cos of x. The next one. So I'm assuming the anti-clockwise direction. So the next one is sine of x. It will be the cosine of the very denoted letter, that is cos x, over the cotangent of x. Next one is cos, So cos of x is given by cotangent all over cosecant of x. So it is cotangent of x over cosecant of x. The next one is the cotangent of x, given by cosecant all over secant. The cosecant of x over secant of x. Then cosecant all over tan. It is secant of x all over the tan of x. The next identity is secant. Secant of x is given by, here is cosecant of x. So secant of x given by tan of x over the sine of x, tan of x over sine of x. Then let's assume I'm moving the anti-clockwise direction. Don't worry. It will give you the right formula. So let us start with the tangent. Tangent of x is given by, now it is secant over cosecant, because we are moving this way. So it is secant of x over the cosecant of x. Cosecant of x. Next one is secant. Let us go this way. So it is sine of x is given by the tangent of x over the sine, the secant of x. So it will be the tan of x over the secant of x. Next identity is cosine. So cos of x given by the sine over the tangent, sine of x over the tangent of x. Then the cotangent cot x given by the cosine over the sine. Cosine of x over the sine of x. Then cosecant of x, the CSC of x, is given by the cotangent of x over cos of x. Cotangent of x over the cos of x. Then lastly, the secant of x. Secant of x given by the secant of x given by the cosecant over the cot. Cosecant over cot, but of x. So one simple hexagon giving you 12. Let's use another figure, that's a hexagon, derive some other formulas. So here we agreed that it is, here is tan, then tan given by the sine over cos, then cot opposite to tan, then all this is the right side, so it is cosecant remaining with secant. So I'm going to focus on, so here we have 6 triangles, so I'll focus on 3. So let me show them. So the first one, the second one, then the third one. So moving in a clockwise direction, this way. So you have to square all the identities included with the one here. So if you square from this perspective, so I will start here. So it is sine squared of, let's say, an angle theta plus the square of this cos, the very angle, cos squared theta, gives you 1 squared. So 1 squared is 1. That's the first identity. The second one is here. So it is 1 squared plus cot squared theta equals to cosecant squared theta. So 1 squared is 1 plus the cot squared theta gives you the cosecant squared the very angle. Then lastly, it is here. So it is this squared plus this squared gives you the square of that identity. So it is tan squared theta plus 1 gives you the secant squared of the very angle. So this is in clockwise direction. Let's see when you use a anti-clockwise direction. So you will draw your arrows will be like that. Speed. So the first one, it is 1 plus cos equals to this, so it is 1. So the sign changes if you move the other direction. It is minus cos squared theta equals to the sine squared theta. Next one, it is the cosecant squared theta minus cot squared theta gives you 1. Then the last one, it is secant squared theta minus 1 gives you tan squared theta. So simple.